Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a topic from the SAT and ACT that gets back to the fundamentals. If you're the age that the SAT and ACT are targeted to, that's to say a rising senior or a senior in high school, this is something that you may have forgotten about. It's something that you probably covered in about a week, back at the end of sophomore year or the beginning of junior year, and so you may just not remember that you did it at all. That topic is completing the square, and it's important for some of the more interesting and tougher questions on these tests. Let's take a look.
Okay, completing the square. First, we need to review perfect squares because getting to a perfect square is why we need to complete the square in the first place. As you'll remember from a previous video, we talked about these. I would recommend going back and watching that video on perfect squares if you're a little shaky on this material, but just sort of breezing through it right now. We have x plus y squared, which is your x squared plus 2xy plus y squared when it's FOILed out. X minus y squared being your x squared minus 2xy plus y squared when that's FOILed out. And then difference of squares down here I've included for completeness. We're not really going to talk about that for perfect or for completing squares, but just going to say, hey, x plus y times x minus y is x squared minus y squared. And even a bit more context, the main area we're going to be completing squares in these tests is when we're converting from standard form to vertex form when we're looking at parabolas. As you can see, standard form is this trinomial with coefficients all over the place, a, b, and c, attached to x squared x and the constant. And then vertex form has this nice isolated perfect square right here. X minus k squared followed out being x squared minus 2kx plus k squared in this case. And so just to talk about the transition from one to the other, we're just going to go for something nice and familiar, like moving from x squared plus 8x plus 16 to x plus 4 squared. Because if you think about it, it's even easier to go the other way, because if you're just following your rules, x plus 4 squared, that's going to be the x part squared plus 2 times x times 4 plus 4 squared. And that's where we get the x squared plus 8x plus 16. And you can see we can just sort of go back and forth between these two really easily. And that's the concept here. And that's what we're trying to get to whenever we complete the square is we have standard form, and then we can move that into the vertex form where we have our perfect square there. But what if they don't? Well, that's when you're going to have to complete the square. And you can see here that I've listed the 5 steps to how you can always do this. I say 5 in parentheses because isolating the x from any variable is something that you rarely, if ever, have to do in the SAT or ACT. So that would be something like if they gave you y equals negative 2x squared plus 8x minus 16 or something like that, you would, since vertex form always has the perfect square in parentheses, you can't have any constant next to the x. And so you have to pull out a factor of negative 2 here. And that would make, going through this process slightly more complicated because you have to be careful what happens when you add something to both sides. But like I said, you probably won't see this. I don't think I've ever seen this, maybe once on the SAT. I think it's out of scope for time constraints on this. So you would say probably don't worry about step 1, step 0 here. Unless you're doing this in school, then that's something you may have to do there. But on the SAT and ACT, basically it's 4 steps. And so let's follow these 4 steps for this example right here. Because you can see x squared minus 6x plus 17, that's not going to be a perfect square, especially because we have this prime number right here. So first thing we do, move the constant over. So let's get a little bit of space up here. We move this constant over. We have y minus 17 equals x squared minus 6x. And then we add b squared over 2 to both sides. So, sorry, b over 2 squared. So what that means is we basically take this, the b value, which is negative 6. We divide that by 2, which is negative 3. We square that, which is 9. And we need to add 9 to both sides, which gives us, on the right side, x squared minus 6x plus 9. And negative 17 plus 9 is just going to be negative 8. And now we factor the perfect square because x squared minus 6x plus 9 is just x minus 3 squared. And then we move the constant back over, which is just going to be x minus 3 plus 8. And hopefully that makes sense. In the interest of time, I'm just going to say here are those steps. If you're working with a tutor, then they can explain in more detail why this is true, how it relates to the perfect squares identities that I put at the beginning of the video. But we try to keep these short. So here we're just going to say, do these things, and you will always be able to complete the square. Okay, now let's apply that to some practice problems. Take a second and see what you can do with these. All right, let's take a look. So first one here, pretty straightforward equation, maybe a little bit of a trickiness here with the -5. So we're going to put the 7 over, follow our steps, basically move the constant over, and then we're going to add b over 2 squared. And so you may have seen me in previous videos be very lazy about what 5 over 2 squared is, just because 5 over 2 squared is just 25 over 4. And so I'm going to add 25 over 4 to both sides. And maybe I'll rewrite 7 here as 28 over 4, just because it looks like I'm going to have a bunch of fractions. And so we have 25 over 4 plus 28 over 4 on the left side. Let's just rewrite that as that's going to be 53 over 4. And then on the right side here, we have x squared minus 5x plus 25 over 4. And I know that I can just factor that to 5 over x minus 5 over 2. And again, being really lazy, I know that 5 over 2 is 2.5, but I like to keep them as fractions because often the answers on SATs are fractions. And then all I have to do is move my constant back over. So that's going to be y equals x minus 5 over 2 squared minus 53 over 4. And that's pretty reasonable. I don't think that you would have negative 53 over 4 as a constant on any SAT question. So it's slightly out of scope there, but still pretty close. And now for the sake of legibility, I've turned this into text here, my answer, so that you can still be reading it while I go on to the second one. All right, let's take a look at the second problem. Okay, the second problem, also a little bit of a reference to another video we have. In the circle in a coordinate plane video, I do reference completing the square in order to get a circle to the proper equation. And so if you've not seen that video, I recommend watching that as well to see this process in practice. So in order to get to the equation of a circle, I need to complete the square, in this case twice. So we have to do it for the x and do it for the y. So I'm going to rewrite this as x squared minus 7x plus something plus y squared minus 6x plus something. And that's going to equal my 13 over 4. And this way I can just sort of keep track that I'm adding the right things to the right places. So we're going to add the b over 2 value squared for the x. And so 7 over 2, I'm going to be lazy again and call that 49 over 4. We need to add 49 over 4 here. Means we need to add 49 over 4 over there. And here we're going to add negative 3 over 2, sorry, negative 3 squared again, which is 9. And as 4s, I'm going to call that 36 over 4, just to keep this nice and consistent. And 13 plus 49 plus 36 is equal to 98 over 4. And continuing with my theme of laziness, I'm going to say, okay, that right there is the radius squared based on the circle and a coordinate plane equation. Just for review, if you've forgotten it, that equation is x minus k squared plus y minus h squared equals r squared, which just means that the radius is the square root of 98 over 4. And again, being very lazy, I don't care what that is. I'm just going to say that it's the square root of 98 over 4. And that, by the way, is a really good tactic to have because you never know how little work you're going to have to do these questions. So always doing less when you know you can do more later is a solid solution.
Okay, that's it for this video. If the concepts behind why we do what we do to complete the square are getting you down, I'd recommend reaching out to us so we can set you up with a tutor to really get in depth with the concepts. Otherwise, fortunately, I've provided you with 5 steps that will always work whether you understand why you're doing what you're doing or not with completing the square. If you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. Thank you for watching, and I hope you have a great day.